Is an extended video for those who are trying to switch the model architectures for the classical machine learning models. This requires you to research a bit more on what you're trying to do. And depending on your data, you might try different types of models. When you go to scikit-learn, they give you these options that are already like grouped together. Depending on what you're trying to do with your model, you should pick a different algorithm, a different type of model, and they list them here. If you're doing classification with which is what we're doing, you can use gradient boosting, nearest neighbors, random forest, and logistic regression. And there are also more in this list. If you're trying to do regression, then they give you these specific models that they have already sort of shown you. And if you're doing clustering, they also have specific models. So you have to sort of know what you're doing first, like what you're trying to predict for before you choose the model that you're trying to switch. With classification, this is what we're doing. When we click this, it'll give us a list of all of the available, let's say, algorithms that we can use. We have tried at 1.4 something called support vector machine. We're going to try these two as well, just so you can sort of realize how it's done. This website is really, really friendly. It gives you some of the code to get you started, so you can sort of step by step follow through. We have done support vector machine, so I'm going to try this one called 1.5 stochastic gradient descent. So when I click this, it gives me sort of a description of what it is, and it gives me all of this stuff. You can read the disadvantages, but all I want to do is I want to try it. I want to see what it does. And it kind of does the same thing as SVM, but they say it's a different algorithm, so why not? Let me see what it really does and if it has a different accuracy level to what I have done in the last video. So whenever you scroll down, you'll see blocks of code, and they will sort of give you an overview of how you can swap what you have in your current code and what you need to keep. So currently, we're importing from linear model, we're going to get SGD classifier. So I'm going to copy this first line, and I'm going to go to my code, and I'm going to open. This is where I was last time, so SVM fitting, and this part where we're selecting the model. So this was from sklearn model selection, we're splitting, and then now we're trying to train this model. So I imported from, sorry, I imported from here sklearn import SVM. This time I'm trying to swap this with this. So rather than using SVM, I want to use SGD classifier. So I don't need this line anymore. I'm going to use SGD classifier. Let me close this. Now, what it says is you still need an X and a Y. The X is your training data. Your Y is your training labels. So sometimes you'll see them labeled this way. So X is training data, Y is training label. You can see that these numbers kind of make sense. The 0 is the first class name, the first label type, and then 1 is the second label type. And then it says all we need to do is do this. So I'm going to replace it here. And now you have different values. You have something called loss. And whenever you hover, you put your mouse over a certain variable, it can sometimes give you like the options. You have hinge, you have log loss, you have log, you have modified Huber, and so on. And you can try these different values, but you should always check what they mean before you change them. There's also a penalty, there's L2, L1, and elastic net. And there's also a max iteration, which is a number that you might want to change to see how well it performs. So this is my current model. You have these values. You will be able to find what these values are within the same page. Let me scroll down. So, sorry, this is a bit too far. It tells us right here. Sorry, here we are. The concrete loss function can be set via loss parameter, and it supports the following functions. We have hinge, modified Huber, and log loss, and it sort of gives you a description of what it is. You can also check the mathematical functions if you want to see exactly what it does. And the penalty, also the same thing, gives you a description of what it does as well. So let's just leave the values as they are. You can experiment with them to see how well they do. And the last step is to just fit it. It is currently the same code that we have, so we don't have to do anything. We're just fitting our training data and training labels. Um, in the code on the website is given as X and Y. We've just renamed our variables to training data and training labels. So I'm going to replay everything to see what it does. So I'm going to start from the beginning, which is here. I'm going to load my data. I'm going to pick my type, which is SGD classifier. It's going to tick. Now I'm using SGD classifier with an iteration of 5. And then I'm going to see what my accuracy is. So my accuracy is 61%. And I got 81% with my SVM, but I have not tried the changes that I've made. So let's say maybe a different value of the ratio might change something. So let me draw a different line here, just so we can split this side. And I can say SGD classifier. And then say first run, I got 61.2%. And from 61.2%, maybe changing this ratio over here might make a difference. I'm going to change it to 0.2. I'm going to start again, play from the beginning, play this, say this, say this. I get 75%. So by changing the ratio upwards, by giving more sort of data to the test side, I got better results. So second run, I have 75.45%. So now this is my second run. Maybe there's things I can change. So let's say I'm going to play around with these numbers. Maybe I should try 10. Let's see what that does. So I'm going to replay. I'm going to load my data. I'm going to split them. I'm going to do that. And now I get 77%. Okay, that's a good thing. So I see my third run, I get 77.27%. Maybe I should make this number really huge. What would it do? Let's say I make this number 50. Let's see what that does. So I'm going to replay from the beginning. So I replay it, I get 79%. So I'm seeing, maybe that's a good thing. So I'm going to say, fourth run, I'm now going with 79%. So 79.09%. So this is when changing the iterations. And currently the iterations are 50. Maybe I should make it really huge. Let's see what that would do. So I'm going to make this 200. Let's see what that does. Does it really go over 79%, or is it just going to be the same there? So I'm going to run it one more time. I'm going to run that 200 times. And when I play it, I get the same thing. I don't get anything better. So I know that at 200, it doesn't really do anything anymore. So 50 was as good as it got. Now I have these changes as well, penalty and loss and penalty. You can try these by yourself if you're continuing with this extended video for machine learning with these classical models. Try changing them, see what values you get. So this is SGD classifier. I'm going to switch this now to the next one. So we have another option called nearest neighbors. So in nearest neighbors, we have something called KNN, which will look at the nearest neighbors and figure out what how to sort of divide up the neighbors, the boundaries. So there are different types of neighbors as well. There's also an unsupervised nearest neighbor version of this. Currently, we're doing something called supervised learning. We are giving the class names to the models, so the model knows what everything is. So I'm going to scroll down and find something called K nearest neighbors. Let me see if they have something called K nearest neighbors. Classification. Okay, so under 1.6.7.1, they have something called K neighbors classifier, and this is supervised. So they give us some code as well. Let's see how to use it. So they tell us we can get K neighbors classifiers, and we also need this code. Okay, so let's take it step by step. I'm going to import this, which is here now. I'm going to replace this with this. Then it also tells me to load these. So I'm going to load these as well. Okay, this seems to already be loaded, so I don't need this twice. Then it says load using iris your X and your Y, and then return XY true. This, I think iris is a data set, so this is not something we need. So we don't really need iris. Okay, so all we're doing is we're doing the same split. This one has a test size of 0.7%. But we already have split our data in train, test, train labels, and test labels. We are currently 0.2. That's fine with me. The next step, it says to get an analysis with this random state. I'm going to perform both of these. So I'm going to copy both of this code, and I'm going to put it right underneath here. So it says use these. I'm going to have three neighbors because I have three neighbors in my data set, apple, banana, and orange. And then I have a pipeline, which is what I need as well. So I'm going to call this pipeline first, which is now what we're getting here. Let me call this pipeline. The pipeline is the whole concept of the model. So I can just say this is my model right now. And then it says NCA pipe.fit, which is the same thing as this. So I'm going to model.fit with this data. And then we're doing the same thing, but this time it's checking the score of the test. So we're not using the same accuracy score. There's something else called NCA pipe score. So this is my model's score. I'm going to comment this out, and I'm going to say, so it's going to take the X test and the Y test, which is the test data and the test labels. So I'm going to call my model dot score test data, test labels, and that will give me a value. So I'm going to say this is my accuracy. Accuracy equals this, and I'm going to print it. Accuracy. Okay, let's play them. Let's see what happens. I'm going to start from the beginning. I'm going to load my data set. I am going to perform my split, which is 80 by 20%. We're using KNNs with three neighbors. Okay. I'm going to start my pipeline, and it's going to fit. Let's see how long it takes. Okay, it has done my pipeline. Then I'm going to play this. We don't really need this anymore if we're doing KNN. So you see most of this code goes away. It's a little bit different. Let me delete this as well. So currently we're just doing this. This is the way the code has taught us how to use the score on KNN. I'm going to play it. And when I play it, I get 91.8%. So I'm going to have a different, I'm going to say this is my KNN classifier. And I'm going to say for my first run, I got 91.81%. So this is how KNN, it shot up all of these. None of these got to 90%. This one got to 91.81%. With KNN, there's not much to change. It's just your like some of the test sizes that you might want to change your test size in your train set. The random state, you can remove it completely to see how it performs without any specific random state. However, most of this data, like the neighbors three, you can't really change because you only have three neighbors exactly. So some of this stuff is specific. You can't really outperform this. So let's see what a different test size would do. Let me change this to 0.3 to see if it will improve my accuracy. I'm going to replay from here. Again, replay, and then check how much more accurate. When I changed the split size, it got worse. So I'm going to log that as well. Second run, it became 81.1%. This is by changing the ratio to 70-30. So that was not a good thing. It did not like that. Maybe I should go the other direction, make it a little bit smaller. I'm going to make it 0.1 to see if that has an effect. I'm going to replay from the beginning. I'm going to play that. And I'm going to retrain. I'm going to fit it. And then I'm going to check for my accuracy. When I check my accuracy, it's 85%, so it's not really that good. So we know a 0.2% split was the best we ever had, so this was okay. I'm also going to log that just so we have information. I'm going to say for my third run, I got 85.45%, changing ratio to it was 90-10, and this was the ratio was 80-20. So we realized 80-20 was enough. We got our 91.8%. And similarly, all your models can be saved this way. However, whenever you're saving them, you should always try and name them properly. So let me rerun this so I can get my 91% first. I'm going to change 0.2. Yes. Replay, replay, replay this one, and then replay this one. So I have this model, it's better accuracy. It would be easier to know that this is my KNN model. So rather than saving as SVM, I can say this is my KNN model. And then I can just maybe underpin a 91 here, just so I can remember in my head that this is 91% accuracy. Also the class names, you might want to rename them as KNN class names underscore 91. This is one way of redefining your models like this. Also, you can give them names like this, and then you can add a new folder inside of model. So I can say this is specifically for KNN, and then I'm just going to add another path here, just so that my KNN models save in a different folder, just so it's more organized later on. So when I save it, inside KNN, we have our KNN class names and our KNN models. And I can do the same thing with predict from model. I can just change my model type. So I can say, go into KNN. I want you to import KNN model. And I want you to also go to KNN, import KNN class names. And it's the same thing. I just want to see if it's good, if that 91% is actually real. So this is an orange. We're expecting this to say orange. So I'm going to play it. And it says orange. So that means that 91% is actually good enough. So these are the two models, ways I've shown you how to change the architectures within your code. It follows the same concept. You can try different versions of these, look for something you might like, maybe decision trees, see how it works for you. Just remember that whenever you're stuck, there is instructions, just read them. There is code for you. Just look around, copy what you need, and try out new things. But it always follows the same kind of pattern.